In this video, I want to talk about the difference between accuracy, precision, and significant figures. You have been using these terms not particularly well over the last few years, and I want to try to make some sense out of them and give you a little bit more rigorous idea of what's going on. First of all, let's talk about significant figures. The number of significant figures in a quantity is a reflection of the precision with which the measurement of that quantity has been made. I mean, for instance, the first example here is the difference between millimeter and centimeter markings on a meter stick. It could be operator incompetence. It could be inherent difficulty in measuring the consistency of how you do the measurement. Let me sort of pause what I'm showing you here and grab this thing here. This is a meter stick. All right, on this side is 1 meter. And it's the same meter stick, but you can see it's sort of square. If I sort of stare at you there. There you are. So it's 1 meter long. If I rotated this way, this is just 1 meter. Right? There's no markings on it other than 1 meter. It's 1 meter from here to here. If I rotate it this way, it's been broken up into tenths of a meter. So, each one of these is a decimeter, a decimeter, okay? And I can break up each of those tenths into tenths, and I have centimeters, right? So you go down and you see the centimeters there. And I can rotate it even more, and you can get down, you can take those tenths of tenths of tenths and get down to the millimeter, okay? So this has more precision than this, which has more precision than this, which has more precision than that. It's the same meter stick, okay? It's the same length for each one, but the precision depends on how well you're doing the measurement. If you're using this side, you're not doing a particularly good measurement. If you're using this side, you're doing the best that you can with the device that you got, okay? Operator incompetence, well, you know what that is. I mean, it says 40 there and you think it says 60 or something like that. But it could be just you're lollygagging with your friends and you just jot something down and you're not using it as intended, just because you're messing around. It could also be the difference between measuring it like this and measuring it like this without my glasses. Things get a little blurry there without my glasses. All right, so that all plays into what precision is. And that's not necessarily reflected by significant figures, okay? So let me go back to this thing here. So again, the first one there is obviously what I just showed you there, millimeter versus centimeter marking. How fine a grid is it? Operator incompetence, I throw that really in there as a joke somewhat. But if you're paying attention to what you're doing, you're going to make a better measurement than if you're not paying attention to what you're doing. And then you have the inherent difficulty in measuring measurement consistency. Again, that could be the fact that I don't have my glasses on, or I do have my glasses on, or you're trying to measure something that's just inherently difficult. You want to find the height from the ground to the roof. Well, the ground is rough. It's not necessarily a well manicured lawn, perhaps, bunch of rocks, and the roof has whatever on it. The tiles, the roofing stuff overlaps each other. So, how do you make that? Depending on where you make the measurement from, you're going to get a slightly different result. Okay. For example, if you take a standard 8.5 by 11 sheet of paper and you measure the width, if I did this not particularly using, say, the centimeter size, I can measure 21 centimeters. And now, what do I really mean by 21? There's a couple of things going on here that I want to point out. Let's get the pen. When I say 21, like I have right here, what does 21 mean? Now, of course, this first one has 2 significant figures. The next one has 3. The next one has 4. You guys all know that. But when I say 21, what does that mean? In reality, 21 is somewhere between 21.5 and 20.5. That's what we really mean by when we say 21, right? I put on here plus or minus. This is a better. Where's my pen? Okay, these things here are what I think of in terms of precision. Okay, placement. This is the units place that matches the units place here. This is the 10th place. It matches the 10th place here. This is the 100th place here. Matches the 100th place here. The precision that you write down here has to match the number of the significance of the number of the value itself. Okay, so you have those different ideas, but I mean you can measure something to if you didn't measure particularly well, you use the centimeter as opposed to the millimeter scale on the meter stick. You might measure it only to 21 centimeters, and if you're going to have it, if you're going to write it down as precision, it would be plus or minus 1. If you did it better, right, I paid attention to turn it to the millimeter scale and measure to the nearest millimeter, it would be 21.6. Okay, the 21 is you measured it using the centimeter scale. The 21.6 you might have used the millimeter scale. The 21.59 you'd be hard pressed using the millimeter side of the meter stick to get that. But I mean, it could be done. In fact, you will be doing this on one of the labs in the not too distant future next week, where you measure something using on the millimeter scale, right? So I have a millimeter scale, and I lay it down next to something, and I take a photograph, and then I take that photograph and enlarge it. Now you can, everything is enlarged there, and you'll be able to get better precision just from the same measurement, but using better technique. Okay, so we can increase the precision. Okay, contrast that with accuracy. Again, precision is how well you made the measurement. Accuracy is your ability to reproduce a standard. What you guys have been taught in the past, I mean, accuracy you taught as reproducing the number. You get the number you're supposed to get. If you know what the number is, why are we measuring it? All right. And accuracy has it's not the ability to reproduce the number, the expected number, because you don't know what the number is necessarily to expect. The ability to reproduce a standard. What does that mean? The ability to reproduce the standard meter, for instance. Okay. If you measured let me give you a really weird example. If you measure the width of a standard piece of paper, right? Width of a standard piece of paper is about this, and you said it was 47.38295 meters wide. That's wider than this room, right? That's like half a football field. If you said your paper was like your paper this big was half a football field, that's wildly inaccurate. Okay. Give you a better example perhaps here. For precision accuracy, on the left-hand side, I have the ILS. That would be the International Length Standard. So we replace the meter with that thing, okay, that you see there. That red line going across is just extending that length across. So I made that mark by taking the ILS and putting a red pen on top and then just slide it across the floor. SWW is the meter, is the ruler that school without walls will be using. So that's the penguin ruler. And WHS, I'm assuming that Wilson is your arch enemy. So that would be the Wilson ruler, okay? And we're going to use those three devices to measure the height of that fence that you see down there, okay? So rank the accuracy of those three devices, okay? Rank the accuracy of the three devices shown in measuring the height of the fence below. Okay, and the answer is the ILS, the International Length Standard, is 100% accurate. That is the standard. The ILS reproduces itself. That is the definition, right? I'm assuming here we replace the meter with the ILS, right? The penguin ruler better reproduces the length. You can see it's almost quite the same length, right? It's a little bit shorter than the ILS, whereas Wilson's is longer than the ILS, but more long than the penguin ruler is short, okay? So the penguin ruler is more accurate than the Wilson ruler, okay? but they're both not as accurate as the standard itself, right? And they're not measuring the, they're referencing they're referencing the ILS, but they're measuring the height of the fence, okay? It has nothing to do with how many times you measure it. You just measure it. You have a single measurement, and we could talk about the precision of that single measurement. We could talk about the accuracy of that single measurement. We don't need to do multiple measurements. We do multiple measurements to make sure that we're doing things correctly, but we don't need multiple measurements to come up with a precision and or an accuracy, okay? So accuracy is the ability to reproduce the standard somehow, some way. If we're trying to measure the speed of speed of the Blinky car, we did the Blinky lab already, right? So you measured the speed of the Blinky lab. How accurate was your measurement? That is dependent on how well you reproduce the meter. You use the tile, right? And how well does that tile reproduce the meter? So you have some sort of conversion from the tile to the meter. How well do you have that under control? And how well your stopwatch reproduced the standard second, okay? If that's off, then the more off that is, the more inaccurate your measurement of the speed of the Blinky would be, okay? All right, so that is precision. Accuracy, we can ask the same question about the precision, okay? Of those three devices, which of them will give the best precision? Which of them will give the least precision? And the answer is Wilson will have the best precision. Why? Because look at it. Each of those segments, right, is divided. It's subdivided into many more divisions than the Penguin ruler is, and the ILS only has one. Okay, so even though the ILS is the definition, it hasn't been subdivided. You can, if you came along and subdivided it really well, you'd have more precision there. But I just have a single black bar that represents the ILS. There's no subdivisions in it at all. Okay, so the ILS there would have the least precision, and the Wilson would have the most because it has the most subdivisions there.